is example number 1 in the 9C notes. The first thing we want to do is work through the paragraph to fill in our table. Be sure that you do that carefully because everything else will depend on filling this table out correctly. A bakery sells vanilla and chocolate cupcakes with white or blue icing. Of the 21 cupcakes made, so it's our total number of cupcakes, right? We have 21 total. 12 have blue frosting. So that's a total number of blue. We don't know which kind have which yet. And as we go, let's go ahead and cross out our numbers. Of the 8 vanilla cupcakes, so again, we know that's a total. That's all the vanilla cupcakes. 3 have white frosting. So remember that these 3 white frosting are part of those 8 vanilla cupcakes. Of the 8 vanilla cupcakes, 3 have white frosting. So that goes there. Using the information provided, fill out the chart and answer the questions below. Now, as you look at this chart, there's a lot of missing pieces. But if we just go one at a time, we'll be able to fill out all of those missing parts of our chart. We can fill out any column or row where we only have one missing piece. Okay? So anywhere where there's just one missing piece, let's start there. Here, we've got a column where we have a total and then a part of the total. Now remember, whenever we have a total and we're looking for one of the pieces, we're subtracting. Okay? So 21 minus 8 is going to give us 13. And that's what we'll put here, 13. What do we want to do next? Well, how about we do this piece here? We'll do 21 minus 12 because this is a total and we're looking for one of those missing pieces. Okay? And when we subtract 12 from 21, we're going to get 9. Right? All right. Which one do we want to do next? Well, we always are looking for a row or a column where there's just one missing spot. So let's take on this spot now. We have a total. We're missing a piece of it, so we're going to subtract the part we have. That's going to give us 5, and we'll fill that in. Okay? Which one should we do next? Well, again, we're always looking for something where we just have one piece missing. And that's what's going on now for both of these remaining spots. We have totals for both of those columns. We're missing a piece, so we're just going to subtract. And we can fill in the missing part. So even though we started out with lots of missing parts, if you guys just remember to go systematically and only do the columns or rows where you're only missing one spot, you're going to be able to fill out your table, okay? Be careful so you do it correctly. Now on part 1 of this problem, we're just asked a normal probability question, okay? What's the probability of vanilla? So what's the probability that one of the cupcakes in our whole sample set is vanilla? So we want the total vanilla, that's the number in this category, over our big total number of possible outcomes. So this number here, okay? And guys, remember that anytime we're finding probability, it's always going to be a fraction where the top number is the number in that specified outcome or that category that's in the parentheses. And that's going to be over our total number of possible outcomes, or our big total, okay? What about here? Probability of vanilla and white. So we know we have to be in the vanilla column, but we only want the vanilla that also has white frosting, because and means it's vanilla and it has white frosting. And the number in that category is just 3. And we're over that big total number. Okay. What about the probability of chocolate? Here's a different symbol. That's or, right? Or means we want to count up all of the chocolate and the blue, because it can be chocolate, it could be blue, it can be chocolate and blue. So let's look at those numbers. This is important. When we're looking at the chocolate, these are the chocolate numbers we want to count. This is a total. We're not going to include that, okay? We just want to include the chocolate cupcakes, okay? Then we want to make sure to include the blue numbers. But here's the thing. If we use the totals, see how we've circled that 7 twice? If we were to use the totals, we would add that 7 twice. We don't want to do that. We're only going to add each of these one time. 5 plus 7 plus 6. Okay? And when we add that up together, that's going to be 18. So the probability of one of these cupcakes being chocolate or blue is 18 over 21. And just as a reminder, or is that up-facing symbol, and that means when we have two subsets, in this case chocolate and blue, it could be just chocolate, it could be just blue, or it could be chocolate and blue, so it's that bigger category, okay? And remember is those things that are A, but they have to be B. So it's that smaller category, okay? Just as a reminder, I just want you guys to be really clear on all of these new symbols. Okay, let's go ahead and look at the next part, part 4, okay? In part 4, what we're going to see is a new kind of a question. We've got a new symbol here. What is that? Well, this line, we have our category. We're used to that, right? But now we have this line and a second category. What does that mean? Well, this line, just like we have talked about, this new symbol means and, this new symbol means or, this line we say as given, okay? So when we read this, it says, what's the probability of chocolate given blue? Okay, given. And that's conditional probability. Conditional probability. What that means is that instead of looking at our whole sample space, now we're just going to look at this second category for information. So whatever that second category is, that's the only information we're going to look at now. All that other information we have to ignore now. Okay? So for finding the probability of chocolate given blue, just like we did with regular probability, we're going to find the number in that category, meaning the chocolate category. But now instead of looking at all of those pieces of information, we're only looking at this stuff. So the chocolate number in blue is 7. Okay? What's our big total now? Well, since this is the only information we have to use that blue total. So for conditional probability, the probability of being chocolate, given that we're only looking at the blue category, is 7 out of 12. All right? So let's try another problem, just to get a sense of how we're doing this, okay? I wanted to clean this up so that hopefully we have a little less going on our whiteboard. So let's go down here, and we're going to see that our next problem is another one that's asking about conditional probability. How do we know that? Okay, well, in the question, we see this blue line. And remember, If that was a word problem, we would see the word given. Okay? The first term is what we want to find the probability for. Okay? Like we did in our other examples. But when we have this given and another category, what we have to do is find the probability of white, but now we're only looking at the vanilla category. Well, what does that look like when we look at the table? Well, if we're only looking at the vanilla category, that means we can only consider this data. We have to completely ignore everything else. We can't think about any of those other numbers. And guys, I often tell students, just cover up the other numbers. These will confuse you. Don't look at them. We're only going to consider vanilla numbers. I'm going to go ahead and pop those back up so that you can get a feel for how to do this even if they are showing. So we're finding the probability of white given vanilla. So let's look for the white number. How many are in the white category, but only looking at those vanilla. So we can only look at this information. So white in the vanilla category is 3. On the bottom, we need a total, okay? But these numbers don't exist for us anymore, so we have to look at the vanilla total, which is 8. So when we do conditional probability, the probability of white given vanilla is 3 over 8. 3 over 8. Okay? And that's how you do example number 1 in 9C. Thanks for watching, guys.